everybody, we're getting ready to do Math Strategies 9 through 11 for SAT Math Level 1. Here's my contact email. SAT Math Strategies 9 through 11 for 2.1. SAT Math Strategies you need to know. And there's 32 points here of note-taking. Get my note-taking guide at the email. Page 1, Strategy 9. Underline units of measurement. So if a problem includes units of measurement, underline them as you read the problem. This will help alert you to whether there's a need to make a units conversion so that all quantities you are in the same unit. So unit conversion, unit analysis is big for SAT, calc section. The element of copper has density 8.9 grams per cubic centimeter. What is the number of cubic centimeters in the volume of 3.1 kilograms of copper? Density equals mass divided by volume. So in this problem here, they've given us these possibilities here of solutions. Notice there are two different units of measurement, so convert kilograms into grams. So the units are consistent. Density equals mass over volume. So we have 8.9 grams over over centimeters cubed. We have 3.1 times 10 to the third grams over our volume. And our volume would equal 3,100 grams over 8.9 grams per cubic centimeter. So this is what we're dealing with from up here in the problem. 3,100 grams. 3.1 kilograms is 3,100 grams. And when we do this, we get 3.48.3 centimeters cubic centimeters, and that one was relatively easy. That comes out to be number B here for that. When you do your division here, 348.3. Calculator section grid in. Andrea finished her first half marathon of 13.1 miles in 2.5 hours. If she ran the race at a constant rate of speed, how many minutes did it take her to run the first 2 miles? So change 2.5 hours to minutes first. 2.5 hours equals 150 minutes. So 2.5 hours, 150 minutes. How many minutes did it take her to run the first 2 miles? Okay, here we go. We're continuing with this example here. If x represents the number of miles it takes her to run 2 miles, then miles over minutes equals 13.1 over 150, which equals 2 over x. So we got a proportion here. 13.1x equals 150 times 2. 13.1x equals 22.9, and 22.9 would be your fill in there on your grid in. Strategy 10. Know how to interpret the parts of a mathematical model. You may be with an equation, and go back and read that again on your video or your PowerPoint, students. Example, no calc section, multiple choice, C equals 65 plus N. The equation above represents the cost in dollars of a cable television per subscription that includes N premium high-def channels. According to the model, what is the meaning of the constant 65 in the equation? A, the cost of, and here's your choices here. In general, if a linear equation of form y equals a plus bx is used as a model, constant a is the starting amount for the quantity that y represents. The constant is the rate of change. So in this instance here, fixed amount by which y changes each time x changes by 1 unit, or slope. Constant 9 is the amount the cost increases when no premium channels are ordered, so C would equal 65 when no premiums are ordered. So the cost of the subscription will be does not include any premium channels. Correct choice is B. Example, no calc section. Connor invests a sum of money at an interest rate of 3% per year, compounded annually. The value of an investment y after n years can be calculated using this equation here. Y equals ax to the nth. If he invests $250, what's the value of his investment after 10 years? So, and then these are the possibilities here. Compounding is exponential growth process. So here, excuse me, be 250 times 1.03 to the 10th power. Choice is D. Notebook, page 9, strategy 11. Match up the same terms on opposite sides, so of an identity. So the equation 1 plus 1 equals 2 is an example of identity. The equation 2 times x plus y equals 2x plus y is another example of an identity. An identity is an equation that is true regardless of what the values are substituted for any of the variables. If a plus 5x equals 2 plus 5x for all values of x, then for this identity we know that a must equal 2. When an identity has opposite sides with exactly the same form, then matching up corresponding terms may help you solve a problem. So page 10. Example, no calc section. And then here we have this expression here. Is true for all value of x. What is the value of b? So we have to find the value of b there. The product of the last terms of the binomial factors must equal to 45. Hence 9a equals 5. Use FOIL to multiply x plus 9 and x plus 5. So this becomes x squared plus b plus 6x plus 45. So here is our trinomial here. Find b by setting matching constants equal to each other. So 14 equals b plus 6, so b equals 8 in this situation here. Grid in 8, so you would go down here and grid in 8 here. Page 12, example calc section, multiple choice. We have two equations here. If p minus q equals this trinomial for all values of x where a, b, and c are constants, what is the value of c? And then here are our choices for c. Express p minus q in terms of n. So p minus q here in terms of n equals 3n minus 2 times quantity 5n minus 2 minus 4 times 2 minus 5n, which is this up here. And then we multiply through here. Factor out 5n minus 2. Here's a common factor here. So we factor out 5n minus 2, and we have 5n minus 2 times 3n plus 4. Find c. So now 5n minus 2, 3n plus 4 equals ax squared plus bx plus c. C must be equal to the product of the last terms here. So c would equal negative 8. That is one way of solving this here. Page 14, calc section, multiple choice. Here we have a binomial here which equals this. If the equation above is true for all values of x and a plus b equals 10, what are the possible values for the constant k? So here are our choices here. If the two binomials are multiplied together, the product of the coefficients of the x squared terms must be equal to 21. So AB equals 21. Since it's also given that A plus B, you're looking for two numbers that you're looking for two numbers 3 and 7 would satisfy those conditions. Because the placement of 3 and 7 in binomial factors matter, there are two possibilities to consider. This, which would equal that. This would be k here. That's one possibility. And then another possibility here would be 25 if you rearrange these two here. So it'll be 5 and 25. That's one way to do it, is having a good knowledge of binomials and trinomials here that come from two binomials. This animated PowerPoint math video is available here at this email, as well as other PowerPoints and video and worksheets and tutoring. Thank you very much.